We all know time travel isn't possible for an object with mass, but what if I told you there was a way we could make time pass slower? The twins paradox describes a scenario in which one twin remains on Earth while the other makes a high-speed journey into space and back.
The twin in the rocket arrives back on Earth younger than the twin who stayed.
This is actually an example of time dilation, which can be explained using Einstein's special relativity. We're all familiar with some form of relativity. Anyone who's studied physics knows the common example of throwing a ball on a train.
If you throw it in the direction of the train's motion, it may appear to go at 1 meter per second to you, but appears to go 1 meter per second plus the speed of the train to a stationary observer.
While this additive form of relativity works for speeds we regularly achieve here on Earth, once speeds begin to approach the speed of light, relativity becomes more complicated.
The speed of light is a universal 300 million meters per second relative to any observer, whether they're moving or not.
Because of this, additive relativity doesn't work.
If I'm going half the speed of light to a stationary perspective, light doesn't appear to go half its speed when we shift to mine.
In order for us to change from one moving perspective to another, we must perform what's called a Lorentz transformation.
This involves a stretching of space and time that allows the speed of light to remain constant from both perspectives. Say you're standing still while a ball moves away from you at half the speed of light. Here we have light moving away from you in both directions. In order to shift to the ball's perspective, we must squeeze the graph in a way that transforms the slope of all vectors except for the light ones, like this. That's how a Lorentz transformation works.
Let's apply this to the twins paradox.
Let's call the twin on Earth the pink twin and the twin in the rocket the blue twin. The motion of the blue twin from the pink twin's perspective can be graphed like this. As you can see, from the pink twin's perspective, the blue twin travels for 5 seconds before they turn around. However, if we perform a Lorentz transformation to see things from the blue twin's initial perspective, we can see that they only travel for about 4.5 seconds before they turn around. If we shift it again for the blue twin's perspective while they return, we can see that the same is true, meaning the pink twin experienced a total of 10 seconds passing, while the blue twin only experienced 9.
So you see, the twins paradox isn't actually a paradox at all, just an example of Einstein's theory of relativity in motion. And hey, maybe you could even use this knowledge to live a little longer. All you need is a rocket ship.